Hello! Welcome to our another week of Techno App subject. Again, I'm your teacher, Shalame W. Pareha. For week 6, let's talk about digital thermometer and temperature indicator. Again, this is under the subject Techno Gadget. Temperature is an expression of how cold or how hot an environment is. There is no doubt you know how one temperature differs with one another, but we always argue about what the room temperature is. Through temperature sensors, you can know exactly what is the environment's temperature. Temperature and its conversion. Temperature is the degree of hotness in a substance. The SI o System International or the standard unit of temperature in the International System of Units is Kelvin. However, Celsius or centigrade is the most commonly used temperature unit around the world. Celsius scale sets the freezing point of water at 0 degrees Celsius and the boiling point of water at 100 degrees Celsius. Fahrenheit is another unit of temperature and most commonly used temperature scales in the United States. Fahrenheit sets the freezing pot of water at 32 degrees Fahrenheit and the boiling point at 212 degrees Fahrenheit. So this is also showing you the temperature conversion table. So this is from Fahrenheit, Celsius, and Kelvin. So from Fahrenheit, you will convert it to Celsius and then to Kelvin. So this table is your guide on your conversion or on how you will convert the temperature from one unit system to another. Temperature sensors. Temperature sensors are the devices that detects the changes in temperature and converts it to a signal that can be understood either by an observer or device. There are two basic physical types of temperature sensors. So the two types of basic physical types of temperature sensors are the following. So the first one is contact temperature sensor. This type of temperature sensor required to be in a physical contact with an object or substance regardless of matter. A great example is a mercury thermometer that you use if someone is sick. Another type of sensor is your thermistor where the resistance changes when the temperature changes. On the other hand, it operates on the voltage difference of two conducting metals. These temperature sensors are by far the most popular for its simplicity, ruggedness, ease of use, and widest temperature range. The other type of temperature sensor is the non-contact temperature sensor. This type of temperature sensors are used when direct contact temperature measurement is not possible. Non-contact temperature sensors prevents and converts emitted infrared radiation into signal that is readable by either an observer or a device. So, let's create or let's have our activity or let's talk about digital thermometer. In this, we're going to learn how to make a computer-based thermometer that can sense and record ambient temperature. Our activity will help you create a temperature monitoring equipment using TM36 sensors. So the TMP36 sensor is a low voltage analog precision centigrade temperature sensors. The ambient temperature readings will be displayed in your computer using the serial monitor function of the Arduino IDE. So the materials that we need is of course the TMP36. Also, We also need Arduino Uno and one breadboard. So again, the temperature sensors that we'll be going to use is a TMP36 thermistor semiconductor sensor type, which has a low voltage, analog precision centigrade temperature sensors. So unlike the photoresistors or the LDR, these sensors doesn't act like a resistor. Therefore, the only way to read the temperature value from the sensor is by plugging the output pin directly to the analog pin. So to do that, here is an example of our circuit. So we have here the temperature sensors can only take up DC powers or direct current power supply that is between 2.7 to 5.5 volts. So direct connection of a 9 volts battery can be dangerous. So voltage output is directly proportional to Celsius temperature. So it ranges from negative 40 degrees Celsius up to positive 125 degrees Celsius. You can use the following formulas to convert analog voltage reading into the temperature. So I've already give you the table that you can use to convert the temperature. So for our circuit, so this is the temperature determination breadboard view on our left side, and on the right side is the schematic view or the schematic diagram of our activity. So wire the 5-volt supply and ground to the power bus of your breadboard. So as you can see here, that is number 1. So the 5-volt supply and the ground to the power bus of your breadboard is connected. Then for the second step, place your TMP36 sensors in the breadboard and connect the wires to the power supply, output, and ground. So when facing the label, the power pin is located at the left, output pin in the middle, and ground pin located at the right. The output pin should be connected to A0 pin of the Arduino, and make sure that these connections are strictly followed. So if you are already done with the connection or setting up the breadboard and the wires, and then also our Arduino Uno are already connected, so let's proceed to coding. So this is the code that you're going to use. Of course, to explain the code, the output from the analog TM36 sensors will be read by pin A0 through the command analog read to be stored eventually to an integer variable sensor val. So sensor val will have a value in the range from 0 to 1023. The reason for this is that Arduino has automatically converted the sensor's output voltage into digital form. So to read the sensor's actual voltage output, divide the sensor's value by 1023 and multiply it by 5. So that is TMP36 sensor output is, as we have already said, 0 to 5 volts stored in the voltage variable. The float data type differs with integer data types as it accepts any number with decimal points. This voltage will be shown in your serial monitor using the serial.print command. So in order to get the actual temperature reading, multiply the voltage reading by 50 and use serial.printint command to display the temperature value in the serial monitor. So once the code is completed, you just need to upload the program to your Arduino board, or as we're going to use it in our Tinkercad for our simulation. You can see that the temperature reading would be close enough to the actual ambient temperature in real life. So with that, the teacher, or as we go along, we will have our exercise and the teacher will give you follow-ups on how to create your own temperature reading using Tinkercad for our simulation activity. So, if you do not have more questions or clarification, let's proceed answering our objective test and performance test. Also, after answering our objective test and performance test, you can provide some comment if you have any more questions or comments or clarifications or suggestions to improve our class. Do not hesitate to send me an email, my contact number, my Facebook account, our MS Teams account, and I would like to say thank you. Stay safe and happy learning, everyone. See you all next week.